Section 2.9 is about combined and joint variation. So what we're going to do at this point in the chapter is take our direct variation and our inverse variation and put them together in one equation, because most of the time you have more than one factor in equation. So the term combination variation means when we have multiplication and division going on, and joint variation means when we only have multiplication. So those are your two terms for today. So if we take a look at example A, z varies directly with x and inversely with y squared. So first thing we want to do is just kind of practice writing these equations. So it kind of goes together intuitively. So z varies directly. So directly means multiplication. So k times x, and inversely, which means divided by. So divided by y squared. Okay, so it should be kind of intuitive. Direct still means multiplication, inverse means divide. So example B, z varies jointly as x cubed and y. So z varies, and we just wrote down that joint means only multiplication. So kx cubed and y. A kind of good rule of thumb, if you can't remember that jointly means all multiplication, if you never see the word inversely, then you would never divide. Okay, so always multiplication unless you see the word inversely. Example C, the volume of a cone varies jointly. So volume jointly with the height of the cone and the radius of the cone squared. So V equals KHR squared. And example D, the maximum weight of a board can hold varies directly with the width of the board and inversely with the distance between the supports. So maybe I would use W for weight, can hold varies directly with the width. So maybe I'll call that D because I can't have two W's. And inversely with the distance, so maybe I'll call that a big D. Okay, so directly multiplication, inversely division, and putting them all together at once. Example E then is going to go actually ahead and try and solve them, and we're going to use the exact same process that we have used before, only we have more numbers now. So first step is still to write the equation. So W varies directly with the square of x and inversely with y. So W equals kx squared over y. So the second step was always to solve for k. So I know that x equals 5. So plug that in for x, still keeping the squared. Okay, really important that you are carrying down all of your exponents here. And y is 2, and w equals 23.75. Okay, so what's going to happen is it's going to be a little trickier here to solve for k. So what my suggestion is to cross multiply all of these, because it's going to kind of keep everything pretty straightforward. So I do 23.75 times 2, which would give me 50, 46, 47 and a half would equal 25k, because 5 squared is 25, and then divide by 25, so I should get k to equal 1.9. So then my step 3 was to rewrite that equation with a k value in it, so 1.9 x squared over y, again keeping your powers all along. And then step 4, plugging in to solve for the question. So find w when x equals -3 and y equals -6. Okay, make sure you're keeping your power, so this is still a square on that -3. Keep in mind when you do on your calculator, you need the parentheses around the -3 so that you get a positive, and then your final answer should be -2.85. Okay, so let's go ahead and try another example. Example F, the kinetic energy of an object varies jointly as its mass and the square of its velocity. So maybe I'll use E for energy, varies jointly. Okay, I never saw the word inversely, so that must mean everything is multiplication, as the mass, so m, and the square of its velocity, so v squared. Okay, so there's my step 1. Step 2, I'm going to try and find my k. So the kinetic energy of an object with a mass of 12, okay, so 12 in for m, moving at 8 meters per second, so that would be my velocity, carrying over my squared, is 384 joules, so I can plug that in for E. So what's getting tricky is here is kind of reading very, very carefully and making sure you're plugging in the right numbers for the right variables. Okay, so read slowly, no silly mistakes here. Okay, so over here on the right side, I'm going to get 12 times 64. So that gives me 768 over on the right side. So to get k by itself, I'm going to divide by that 768. So I'm going to get k to equal 0.5. So then again, step 3 is to rewrite that equation with my k value in here and carrying through all of my powers. And now step 4 is to solve the equation. Find the kinetic energy of an object with a mass of 8 moving at 12 meters per second. So 8 for my mass, 12 for my velocity. Make sure you square 12 first before you multiply everything through, and you should get 576 joules. Okay, so let's go ahead and try the next example. C varies directly as the square of A and inversely as B. So C varies directly as the square of A and inversely as B. Okay, so keeping in mind inversely means the divide. So step 1, taking care of. Step 2, solving for K. So plugging in 5 for C and 5 for A and 10 for B. Okay, again, please remember to carry your powers through all of these. So if I'm solving for a K in a little complicated situation here, I'm going to cross multiply. 5 times 10 is 50, and then 1 times K is K, and then 5 squared is 25. So I'll divide each side by 25, so I'll get K to equal 2. So step 3, rewrite that equation with my K value in here. So C equals 2A squared over B. And then solve my equation. So C, when A is 3 and B is 4. Again, make sure you should do 3 squared is 9. 9 times 2 is 18. Divided by 4 gives me 4.5 for my final answer. Okay, so lots of algebra, just kind of manipulating it around in different ways. And your last example, H, the wind force F on a vertical surface varies jointly as the area A and the square of the wind speed. Okay, so F equals KAS squared. Okay, now notice, yes, area is usually squared, but it did not say the square of the area. Okay, so I only put the square on the wind speed. So plugging in values, again, read really careful here so that you're putting in the right values. So the force is 340 on a vertical surface of an area of 1. Okay, so the area is 1. I don't need to square it because it was just A when the wind blows at 18 meters per second. So I have 18 and then squared. So on the right side, if I simplify, I get 18 squared times 1 is going to give me 324K. And then I've got 340 over here. So I divide each side by 324. So if I use my calculator to reduce, I'll get 85 over 81. And you do want to keep that fraction. Okay. So in step 3, when I rewrite my equation, I get F equals 85 over 81 AS squared. And now I can finally answer my question, which asks me find the force exerted by a wind. Okay, careful, it gives me the wind first this time of 35 meters per second. So that goes in for my S on a vertical surface of an area of 2. Okay, so square your 35 first and then multiply it through. You should get about 2,570.99 newtons. Okay, so hopefully today is a pretty straightforward day. It's just combining things that you already know into one. So go ahead and write down things you know and things you're still confused about and come with those questions ready for class tomorrow.